Okay, welcome, people of Earth, to day 18 of Advent of Code. Um, I don't really have much to say about yesterday. I was pretty happy with how it went. I guess the broad thing that I didn't say explicitly is you could have tried to do yesterday's puzzle analytically, or at least kind of starting from the target region and then working backwards to the beginning, and that certainly would have been less resource intensive. Whereas I just tried a bunch of numbers and saw which ones got us the right answer. Um, uh, Again, this is earlier in my life slash career. I definitely would have focused on a kind of clever analytical approach, but I, I do think the point of computers is that you can try a bunch of things, and this is something I have to keep like repeating to myself because it doesn't come totally naturally to me. But I like the approach of just if the target space, the space of possible solutions is small enough, go ahead and just explore it, right? And the one thing that because my program did get a little bit slow when we were doing the second part, and the main thing here is just the number of steps that I took in this line here. I was doing 300 steps no matter what. Really, the obvious thing to get rid of all the inefficiency of doing too many steps was to just look here to see if we had passed the target area. And if we had, fallen below the Y and or past the X, we should have just bailed out of the loop at that point and not done any more steps. So that's one lesson. I could have certainly made that, and that would have been probably about 10 times faster because we probably only need a couple dozen steps to get there. Anyway, let's see what day 18 has to offer us. Okay. Pairs. Okay. Hmm. Well, I'm a little confused by all this. Let's see what our input looks like. Oh no. So, are we going to have to actually parse this? Let's just save it, right? Oh my. Um, I mean, this is Swift syntax, so could we just assign it to. Yeah, we can just assign it to a variable actually to avoid parsing. Um, Equals. And then all of this. And close that. And I don't know how to suffix every line with a comma. I don't know how to do column stuff in. There is a way to do column editing in BBEdit. I just don't know what it is. Um, so, oh, there are a lot of them. How many? How many lines is this? Okay. Oh no. So the question is, would writing a parser have taken more than doing the commas? Or really, would looking up column editing in the BBEdit documentation have taken longer than typing all these commas? Um, that is a reasonable question. But, oh my gosh, I'm not very good at it. How many more do we have to go? Why is there a syntax error on that line, I wonder? Oh, I think it's caught up to us. So let's see if this compiles. Yeah, okay. Okay, so we got our input. Magnitude of the final sum. So I didn't really understand what we're doing to these pairs at all. Must be reduced. If any pair is nested inside of 4 pairs. Okay. Oh, what are these types? They're pairs of array, pairs of pairs of pairs of. I don't even know what type it is. It's an array of something, but I honestly don't know how that compiled because it doesn't have a clear. It doesn't because they're not homogeneous types, are they? Is this actually the? Oh no! So we did all that work for nothing. I think. Oh God. So what do we do? It's an issue. Okay, so we're not making the leaderboard this time because I've already wasted 5 minutes and I don't know what I'm doing. So let's read the problem more carefully and come up with a plan, I guess. Okay. Okay. 9 8 becomes 0 9. First. Okay, I think I get what exploding does. Split. Okay. I still don't actually understand what addition means. Well, some of this list. What? What is addition? Oh, to add? Form a pair from the left and the right parameters. 1, 2, 3, 4, 5. Oh, okay. And the result of this list is, yeah. Oh. 2 times is right. Okay, so, how are we gonna do this? We will say that, so what? Okay, and no, that's not right at all. Okay. We should really be using an enumeration here, but I don't entirely remember how to do enumerations. So let's not make life too hard on ourselves. Okay, so no. Oh my God, I'm terrible at this. Pair each element, regular number or another pair. So. And we need to pass the okay. No. Level greater than 3. Okay. If any pair. Okay. Yes. Then. Explode. I hate it when things on my desk are rattling. No. don't know if I actually have the data structures to do this, but let's just get it down. And how do we do this on the whole? No. There might need to be one. Okay. Okay. Let's see if that compiles. There's a lot I haven't worked out. Oh my, what is all this? Num, the recursive becomes. It can't? Sure it can. It really can't? Oh no, that's a. I'm familiar with this in Swift. What's the well, that must be why, right? So we're gonna have to make it a class. And I don't think we need mutating if it's a class, but anyway, let's go through all our things in turn. What? Okay, what are our issues? Yeah. So, none of that. Mutating is only for structs, so we can ditch it. Oop. And actually, it makes sense that structs can't contain themselves because they're just by value, and so we need something that has a pointer in it. So I just wasn't really thinking about how all that worked. What is all this? Come on. Okay. Yeah. That all makes sense. Okay. So, but how do we explode if we have to change something about the parent? That's a bit of a shame. So, okay. So how do we explode? Replace it with a pair. Okay. Do splits. So this is easy. We just say um, r over 2 r plus 1 2, right? So if it's even, then that will round down, and that will, yeah. If it's odd, then that will round down, and that will round up. Yeah. Okay. So let's make sure we got all that syntax right. Not the. How do we do? Oh, of course. Oh. Okay, so still, R is a let constant, is it? Really? Oh. No, that's good. Thank you for catching that, Swift. Okay, that's all good. But the explode, I'm not quite sure how to do because we need to talk to the parents or something, don't we? To explode, left, first regular number to the left. So what does explode mean? Any pair, the leftmost such pair explodes. Left value. But what happens if it's not regular numbers exploding? I'm not really sure how to do that then. Left. Oh, because if it's deeper than that, yeah, okay, because it's deeper. If it's deeper than that, it will have already exploded. So they have to be regular numbers, right? So, um, uh, ba, 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 ba. LV equals. Come on. What are we doing here? Equals. Any. Oh. If. Equals P0. No, we can just do this. And we can actually return P1. Okay, so So now we're changing the semantics here. Okay. That's not right anymore, but this can be nil. Okay, now if P0 do explosions, yeah. So hang on. So the regular number to the left, that has nothing to the left. That is the second in a pair. That's the second in a pair. That's the second in a pair. 1, 2, 3, 4. So you're always going to be the second. What if you're the first of a pair? Pair 7, 3. No, that's the. Oh, it's going to be. Okay. Okay, don't get it. Let's just write the logic for this one. I'm thoroughly confused by my own logic here. P1. So. Then, P0 and what happens? Left my first regular number to the left. First regular, yeah, and it doesn't go back down. I keep thinking this is more complicated than it is, but yeah. But you're only going to get regular numbers, and there isn't going to be multiple nesting and yada yada because explosions will only go one level up. Okay. Add to the first regular number. To the left. The pair is right value. First regular number to the right. So where does that go? So that, if it's the first number in the pair, you can ignore it. If it's the second number in the pair, then you have to add it. Oh, and you go all the way up to the right. Okay. Well, let's add. Oh my, we're not doing well. Okay, so we do another function. Oh, yeah, and I still don't know how to parse my input, but we've decided to deal with that later, which is possibly not a brilliant idea. Um, so, uh, if it's a pair, then, um, yeah, okay. Um, if, so if our left exploded, then, um, we say, ba 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 ba, um, P1 left, the right value, and then okay. Whereas if our right exploded, then add the left value at the right, the left value, and the right value, right? I think I'm getting more comfortable with this. And that's if it's a pair. And otherwise, no. Okay. So, do explosions. And now we have to see do reduce. Do explosions. Okay. So, okay, so if we explode something out and there's nowhere for it to go, then it just disappears at this level. So I think we're actually um, do explosions. Okay. I got that stupid thing. Oh. Add. Where did we do add? 119 and 126. Pair. To the left. Yeah. Left pair. And then we have to the right. Okay, so that kind of works. Do okay. So how do we let's create a string initializer. Oh no. Okay, and oh no, that's not enough. We need a position, don't we? Okay. If S then and we need. Oh, of course, this is always a thing, isn't it? Yeah, I know. I forgot my. Okay. Oh, I have to actually do it, don't I? String of this. So I need to just get that one digit and just make it happen. I could assert that it's a digit there, but the int thing is gonna make it happen anyway. So let's see if our parsing routine works now. Let's use this, shall we? Come on. Let's just see if our parsing routine works. We're being quite slow today. That's just how things are going. Oh. What are you talking about? Oh, and pause. Okay. Good. Still not right. To be an in-out parameter. Yeah, we know that. Yeah. Oh, okay, it worked. So, and I mean, we're being so slow that we're gonna have to write a visualizer anyway. So, what is the? I forget what the canonical name. I don't remember what the canonical name for the stringifying functions are. So. And really, all this code would be simpler if we would had actually used an enumeration. It would be much cleaner. So if I had to do it again, I would go back and do it as an enumeration. But uh, because there are recursive enumerations in Swift. It's actually a very nice feature, and I just wasn't in the mood to use them, and that was probably a mistake. How do you stringify something? You know what? It's come on. It conforms to custom string convertible, I think, right? Description. Yeah, here we go. That's what we're looking for. Description. Okay. Oh, come on. Zero. This is we've spent 40 minutes on this, and it's quite a straightforward problem. So, you know, but it's not a fun problem. It's just very picky, and I've programmed it very awkwardly. So, I don't really object to the problem. It's fine, you know. I'm just not doing particularly well. 124. How did that break? Nope. Missing return. Line 120. Oh. We should really do that 130 and 133. And are we in an infinite loop? It looks like we are. So let's... well, I suppose that's good to know that we've done something stupid. So reduce is repeat while b. So okay, so what's going on here? What? Bar description. We need to. Oh. So, come on. Okay. So what happened here? 981234 is good, becomes 09234. Oh, I didn't apply this rule. Then the entire exploding pair is replaced with 0. Yep. That is a thing we didn't do. If I like the defer statement. It's very pretty. You have to do it with destructors in C++. So it's a convenient way. Because this way we can preserve... I'm talking too much. I could have saved more time just doing it the ugly way. So what am I thinking? 0 pair equals nil. Oh, actually, I don't think we even had to defer this, did we? Because we already had captured this pair with P, but let's defer it anyway because we're just them kind of folks. Okay, 0, 9, 2, 3, 4. Let's try a big one. Okay, here's the final. Okay, I don't want sums. Process of finding the reduced result of... Oh, plus what? The single explode. To split. Here's the process of finding the reduced result of... So now we have to actually do the addition. What is the addition? To add, form a pair from the left and right parameters. Okay, so a num from two nums is pretty easy. Okay, so let's just knit it from two nums. I might re-implement this as a recursive enumeration because I don't think I've ever actually written one of those. So that would be good experience for me. It compiles. Okay, so what happens if we... n equals... one. Oh, x equals nm, and then let's try reducing x. Okay, so what happens with this whole? Ooh. Num. Still not. I'm not very good at remembering that. Come on. What do we have here? After explode. 074. Ooh, why didn't that do its thing? Let's just see. After addition, 4344784911. Okay, good. After explode, 074784911. Good. After explode, and after a second explode, 07415 01311. This is all looking very good, but then our split is not happening. Do explosions is not nil, or do splits. Oh, and it looks like we're not off by one. So that's a bonus, isn't it? Good for us. So why are we not doing splits? Return if r equal to 10. Oh, what is the... Yeah. Oh. Okay. Now what happens? Okay, and we get to 074786081. So maybe we have a working something. Um, adding up a list. Okay, so let's ditch. I still don't know what type this is, because Swift somehow parsed that, but I don't know what type it parsed it as. That's crazy, isn't it? So we got all this crap here. Okay. For L in lines. No, hold on. Data lines. Num of lines 0. So let's what? Data 0. Will I remember the ampersand? Yes! I did remember the ampersand, so that's a positive. Okay. Now, for L in data 1, we are going to add n equals num of n and num of L pause, which we set to 0. No, we don't need that. Oh, why was that unmatched? Oh, because that's why. Yep. Okay. I wonder if this runs. Okay, it ran. So what's our final score? Check whether. Let me check the magnitude. Magnitude of a pair is 3 times its left plus 2 times. Okay, so one more function here. I've been putting them at the top so I can see what my two fields are called, but I'll see if I can remember. Pair 0 mag times 3 plus pair 1 2. Okay, I don't know. Maybe. This is only part 1. We've taken almost an hour just to do this part 1, but we did get the right answer, so that's something. Oh, and I'm only 351, so actually everyone is having a hard time with this today. Okay, what is the largest you can get from adding only Oh, okay. Um, there aren't enough numbers for us to avoid doing the obvious thing. Let's, because we're gonna delete a bunch of our code. So, no, yeah, that's fine. 4. We have no chance at the leaderboard because this is a very small edition and we're already in the 350s, so it doesn't really matter. But I am on some private leaderboard, so I might as well do it moderately quickly. Da, 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 da. Oh. No, we've actually every time we reduce, we're destroying stuff. So let's build everything from scratch. That's a fairly serious design flaw if this were in a general purpose library, that we're destroying things when they're nested because of their nesting. We change their structure. That's not very good, but that's fine. And what is the largest let's see how this goes. No? Oh my god, you see how bad I am at this? I'm just atrocious at it. We could have removed those print statements, couldn't we? But okay, so we took almost an hour to do that whole thing, but it turns out everyone, I mean, not everyone, we can actually look at, some people must have got it. Well, it took everyone half an hour. The leaderboard didn't fill up until 43 minutes, so that's about 15 minutes ago. So, I do wonder what it would look like using a recursive enumeration, and that wouldn't be terribly hard to implement. So I may toy with that on my own time, but there's no real pressure for that, and it's getting a little bit late. So I will just see you tomorrow for day, what is it going to be, day 19 tomorrow? So see you then.